Your FastMCP server's responses disappear every time it restarts, leaving users waiting for the same slow operations repeatedly. We'll configure persistent disk-based caching so responses survive restarts, using just 2 lines of code to swap from volatile memory to reliable file system storage. You'll see exactly how to set up the DiskStore backend and plug it into FastMCP's caching middleware.
From key value, AO stores, disk import DiskStore. From FastMCP server middleware caching, import ResponseCaching middleware. Hash persistent response cache. Middleware equals ResponseCaching middleware. Cache storage equals DiskStore. Directory equals /var/cache/FastMCP.
This demonstrates the strategy pattern applied to storage backends, where interchangeable implementations share a common interface. The code shows how FastMCP abstracts persistence details behind a unified key-value interface, allowing you to swap between memory, disk, or distributed storage without changing application logic. What makes this distinctive is the complete decoupling of storage mechanics from business logic, achieved through a consistent Async API. The pattern works by establishing a contract, the key-value interface, that all storage backends must implement, while the framework handles the instantiation and injection of the concrete implementation. This creates a clean separation where your middleware or authentication components declare what they need, persistent storage, without knowing how it's provided. The actual storage behavior, whether it's file system I/O, Redis network calls, or in-memory dictionaries, becomes an implementation detail managed through configuration. This approach solves the classic problem of environment-specific dependencies in production systems. You develop and test with memory storage, then deploy with Redis or disk storage by changing just the configuration. The real-world benefit is deployment flexibility. Single server setups use disk storage, while distributed systems share a Redis backend, all without modifying core application code. The trade-off is learning the storage interface contract upfront, but this pays off when you need to scale or change infrastructure. Let's break it down line by line.
From key value, AO stores, disk import DiskStore.
Imports DiskStore, a persistent key-value storage implementation that writes to disk. This handles cache persistence across server restarts, preventing cold start performance hits.
From FastMCP server middleware caching, import ResponseCaching middleware.
This imports ResponseCaching middleware, FastMCP's built-in layer for caching HTTP responses. It intercepts outgoing responses and stores them for reuse, eliminating redundant processing for identical requests.
Hash persistent response cache. Middleware equals ResponseCaching middleware.
This instantiates ResponseCaching middleware, the FastMCP component that intercepts and caches HTTP responses. It sits between the server and your handlers, eliminating redundant processing for identical requests by serving cached responses when available. This is the standard middleware pattern for adding cross-cutting concerns like caching without modifying root handlers.
Cache storage equals DiskStore. Directory equals /var/cache/FastMCP.
This configures persistent response caching to disk, storing cached responses in /var/cache/FastMCP. DiskStore handles the actual file system operations, ensuring cached data survives server restarts and remains available across sessions. This closing parenthesis finalizes the ResponseCaching middleware instantiation. It completes the configuration of persistent response caching using disk storage, which will now intercept and cache responses according to the middleware's rules. Storage abstraction pattern. FastMCP's pluggable storage backends let you swap between in-memory, disk, and Redis without changing your caching or auth logic, using the same key-value interface. Disk storage persists across restarts, but ties you to a single file system, while Redis enables distributed caching at the cost of network latency. The right choice depends on whether you need persistence or distribution, not performance alone.
The cache that remembers nothing becomes the fastest, while the cache that remembers everything becomes the slowest.